Hey guys, so I guess I cut myself off somewhere along the lines, but let's be honest, I don't think anybody's too upset about that. So once again, lactate's a fuel source. You're going to utilize it accordingly in aerobic systems. Specifically, it's going to be converted back into pyruvate, where it's then going to be converted into acetyl-CoA and go through that citric acid cycle. Now, that's only going to happen when we have oxygen available. So if typically our fast switch fibers produce it because it's not able to keep up the workload and how much ATP is needed aerobically. Because of this, it now has this abundance of lactate. Well, the lactate isn't so much the problem as that proton that comes with it, but it still has to ship it out of the muscle. Okay, because the pH is going down, makes enzymes not work as efficiently as possible or as they should, and because of that, they're going to have a decline in performance. Lactate's either going to go to an adjacent muscle fiber, which hopefully is slow twitch fiber. It has the ability then, because it has oxygen available, to convert that lactate back into pyruvate, which gets rid of that proton problem we were having earlier, and we're going to have still that energy production, so we're going to be doing well. Well, on occasion, that doesn't happen. So now that lactate is going to go into the blood. When it goes into the blood, it can go anywhere in the body. Once it can go anywhere in the body, that any slow twitch muscle fiber we've got anywhere throughout is going to be able to be breaking it down for energy. Or our heart, turns out that it is kind of nothing but slow twitch muscle fiber. Our brain and a couple other areas are going to be able to utilize it accordingly. Our liver is going to be able to take that lactate, convert it actually back into glucose, and then release that back into the bloodstream if necessary. Now, these are only going to be done if we're in an aerobic environment. So this is going to be where we're able to break down glucose and fatty acids with oxygen available. So the other side of when are the other macros going to be utilizing this? Or I guess the question was kind of, how does it feed in? Well, it's going to be a part of the energetic system. So in the idea of it's energetically favorable in the fact that it's only going to be really talking about a 1 or 2 step reaction in order to get this done, as opposed to something like beta oxidation, which is a 4-step process, and the big limiting fact is getting those fatty acids into the mitochondria, or glycolysis, which we're talking about a 10-step process, give or take, so that we can get these products that are then going to be able to filter in to the citric acid cycle. So we've got something that can already be put in within 1 step, that's going to burn itself a lot faster. So it has its advantages, but obviously it's that proton that comes with, drops our pH, and causes some issues with function in our muscle, and also gives us that wonderful burn as we're going through. So overall, that's really what we're talking about when we're talking about lactate, as far as the areas that can clear it out, how it's going to be basically produced, and the fact that, once again, guys, it's fuel, it can be useful, but it's when we accumulate too much that we're going to have ourselves some issues with performance. So, have yourselves a great one. Oh, the other thing I didn't throw in there is the fact that the ATP PCR system doesn't utilize lactate at all. However, since it is in that other short anaerobic energy system, it's going to turn us out when that's depleted, that's when we're going to use more of the anaerobic glycolysis. We're going to be producing more and more lactate. So in turn, if we have to use the ATP PCR, it can only be replenished also oxidatively, just like we can only get rid of that lactate oxidatively. So we need to be in a situation where either different muscle fibers, somewhere else in the body can handle that. Now with the ATP PCR, that stays inside of those individual muscle cells, so the only way that can be replenished is if those muscle cells are able to go into an aerobic environment where that phosphocreatine can be restored inside of the mitochondria of the muscle cells. Science. Thanks for watching, guys. Good luck on the exam.